Hi, my name is Taylor Heim and I'm a Solutions Engineer with SAS Institute. I'd like to talk to you today about Adaptive Case Management, or ACM. It's a mobile application we have built using both Appian's Business Process Management Suite and SAS Analytics, and how we think U.S. Census can leverage it to improve the deployment of near real-time analytics to collect more valid respondent data. Many of the requirements that Census is working towards as an organization, including the Decennial 2020 efforts, require an enterprise-level data lake that IT and end users can work with to deploy real-time analytic models that validate respondent information as it's entered. Please take a look at the Hadoop in-memory portion of the video where we talk about the value of the data lake. But Census's usage of administrative data from across government, including Medicare, food stamp benefits, U.S. Postal, becomes particularly powerful in helping establish expectations around address frames in the individuals and families as they migrate across them. In turn, those analytic models can be deployed as a function of census understanding, and respondents can validate and update existing information Census is already collecting administratively within that data lake, and it's purpose-built for that large-scale enterprise collection of information. It's the same technology that Google runs. The IRS Return Review Program has only a 24-hour window to process up to 10 million 1040 tax returns. IRS leverages SAS technology to deploy analytic routines inside the database that rapidly produce alerts for investigators around fraudulent returns. We're helping them rapidly spot identity thieves by alerting and then providing immediate facts about the case and suggested follow-up based upon the pattern we're seeing. With our technology, the IRS estimates they can save an additional $3 to $6 billion taxpayer dollars per year by deploying our technology in production. We've also built analytic applications for the Department of Defense Office of Inspector General. Using SAS Text Analytics, we analyzed their hotline data, which consisted of email, web, and phone transcripts that OIG personnel use to identify threats to military personnel, including suicide. With the use of our technology, we could immediately highlight for OIG's hotline analysts a specific level of risk around an email so they could stop their normal routine to focus on the more immediate and pressing need. Today, we're using CDC data, and this is their Vaccine Adverse Event Reporting System, or VAERS. The reason I'm using this is it's publicly available, and we really need to run those analytic routines on enough observations to obtain statistical inference and provide relevance to the end user. So without further ado, let's actually just launch right into the demo. This is SAS Enterprise Miner. As you can see, it's our predictive modeling tool bench. So I'm going to walk through how we're going to create some of the predictive models and text mining algorithms that interact with the investigator through the case management applications. And again, in this case, we're using the CDC data, which is Vaccine Adverse Event Reaction data. We're going to actually just open that data up right now and take a look at what it is. You can see we're looking for the serious event. That's the target variable. And then we have other data elements around, just case detail around what people have entered into the web form, is what their symptoms are, what type of vaccine they received, etc. So here what I'm doing is just exploring some of the text mining capabilities and looking at concept links associated with the word vomit. It looks like it's actually a much higher weight than some of the other text terms that are in my list here. And I want to associate that with the serious outcome. So you saw that 29 out of the 29 cases of vasodilation associated and vomiting is associated with a serious case. So the presence of that term in any of my text will increase the risk score and chances that I should be focusing on that case as an investigator. So that's all automated decisions that I'm going to suggest to the investigator an increased risk that, yes, maybe you want to check this person out when we get to the case management application. So the next component of our prototype is the concept of triage. So the investor's day being organized by rank order in terms of risk, questions that they need to nail down. So in this case, in the CDC example that we built out the prototype on, we're looking for if something was a serious reaction based on the data that the person is uploading to their form. So in the first 10% of the data, the top 10 of their list of 100 people that day, 7 out of 10 of those first 10 people are going to be the serious cases that they really want to follow up on. So again, we're just pushing all of that underlying information to the investigator so that they can start their day more efficiently and with the right information to follow up on. Now that we've talked about how to create algorithms that assist the investigator with assessing the risk of their underlying cases, we we wanted to touch very briefly on the integration points with the case management system and the analytics system that is deriving those estimates. The first step, as you can see, is triage, and we do this by deploying the SAS algorithms in the Oracle database itself so that Appian can then read those triage scores and raw case data into the case management system so that we can develop a process flow around that work stream. So as the next integration point is, as the investigator enters additional data and wants it reevaluated for risk, a service call from Appian to the SAS architecture dynamically rescores that individual record and puts that information back in the Appian interface so that they can continue working with that case and the additional information that they have on the increased risk. Now I'd like to walk you through the investigator user interface. This walkthrough is based upon the process model that we created to meet investigator requirements, giving them more serious cases to follow up on in an easy-to-use interface. So the first thing is I'm going to go through my triage list of CDC cases that SAS has provided me based upon a scoring of their inherent risk. And I'm just going to go to 50 and 75% risk and go into this case ID. So here I can see it's a pneumonia vaccine. The risk score is 70%, so this is a fairly likely case. The information, around a 67-year-old white male. Patient developed swelling in the red arm from elbow to neck and chest area, red rash, and he was placed on some drug regimen. So I might want to follow up with this. So I can just hit related actions and create a CDC case out of that and start following up on the process within the case management process flow. So I can see I've got that case ready to update. Here I can submit additional symptoms. So again, the ability for the case investigator to add additional data to the case. Here I can say maybe in the follow-up I learned that the patient was admitted to the inpatient floor with violent vomiting, which we know from the previous word strings is a pretty significant variable and would raise the or increase the risk score of this particular case, but we are going to submit it for a rescore, which makes that call back to SAS where it goes through that text mining algorithm that we've developed. And then again, I should see it here in the elevated cases, and there's my case. Again, went from a 70 to an 80% probability of being a serious event, and there's the additional symptoms that I've discovered as a case investigator, again going to that next phase in the process based on the information that the investigator is entering.